Okay, good morning, all of you. Uh, yes, today, before I start, I would like to just highlight or emphasize on one or two points here. Let me wait for a second here. I just see on the screen some of you are joining right now. Mm. Okay. Now, before I go on to the main topic and we start with or continue with our respiratory system, there are two things which I wanted to tell you. Tell you. The first and the foremost was we had the results of the senior batch who have written their anatomy and physiology. I hope that you had got a chance to know about the results, and I am generally speaking about the whole of the state except for the Gandhi and Usmania students. Most of the colleges had a result of somewhere between 45% to 55% pass. Very high rate of failures in most of the medical colleges except the two, that is Gandhi and Usmania. Now, the end conclusion or the summary of this thing is you have to work hard and you cannot do a selective reading or just read what is important for the exam and attempt the examination. Since last year, there were two changes which have been effected. One, the question paper pattern has been changed and it is instead of 50 marks, 100 marks paper, paper 100, paper 200 on all the three subjects. So this gives you a situation where which is different from your senior batch, I mean the 18 batch and the previous 20 years batches who just had a 50 marks paper, paper 150, paper 250. They used to just do selective reading, come to the exam and appear for the exam. And in their case, the Viva marks were added to the theory marks, but from last year this is not there. So this is the one difference or one change in the pattern which has happened. And what difference does it makes to you all if it is a 50 marks paper or a 100 marks paper? The thing is, in this new syllabus or this new curriculum, you should know about everything. If not completely about everything, you should know at least something about everything which is there in the syllabus. Then only you are thorough and you are ready with the answers. If you do some selective reading where you think that something is important and the others are not important and you leave it, then you are bound to have a difficult result. And the paper pattern of yours, just see the paper 1, paper 2. In the previous papers there were two essay questions and some short questions. The whole 50 marks was 12 questions in paper 1, 12 questions in paper 2. Now coming back to your side, in paper 1 you have got 20 questions. In that 20 questions you have got two essay questions which are 15 marks of each, and each of these essay questions are, again, it's not one question but divided into 4 or 5 subsets of questions. So the whole paper 1 will have at least 30 questions. The paper 2 will have 30 questions, that means 60 questions compared to those previous 24 questions. You just don't know some topic, and if the topic question, related question comes to that topic in the exam, you are bound to get 0 out of it. So the end thing to summarize this last year's result is you have to do better and you have to work hard. You have to spend at least 6 to 8 hours every day in toto for all the three subjects, so that you are thorough with the subject, not only with the examination point of view, but also you need to gain knowledge and you need to know the basics. Opportunity is there. We are already into 5th month of your course. February we started. This is the 5th running month. In another 6 months, you will be completing your course in December. Anyhow, I'll come to that a little later. So whatever time you have got left sitting at home, spend at least 8 hours with the books. Divide your time 2 to 3 hours anatomy, 2 to 3 hours physiology, and 2 to 3 hours biochemistry. Otherwise, it will be difficult for you. A last minute reading or just reading just to read the important questions and just giving one reading, 2 reading is not sufficient. Secondly, the advantage, as long as we are conducting on YouTube, you have got the advantage that the classes are recorded. You can hear them multiple number of times. If you have any of your friends in your senior batches, you just have a chat with them and what did they do to prepare themselves. They just went back, they listened to all the YouTube classes again and again, the same topic 2-3 times on different occasions, and that was the revision, and that made them really successful. There were about 3 to 4 distinctions, 3 overall distinctions, and a number of students have got individual distinctions in the subjects. If you have a chance, if you know them, just find out the pattern of how they prepared and how they learned the subject. It is because they revised again and again. You have the advantage of YouTube, you listen to our lectures again and again, or with the textbook you revise again and again. That only will make you to understand the subject and remember it forever. So now this is about the results and the future for you. The second thing would be about your internal exams. Now, the whole curriculum of yours has been divided into 11 months, started somewhere around February 1st, and your university exams are likely and expected to be, final exams, university exams will be somewhere in January. The pre-finals are supposed to be conducted in December 2021. Now, the first internal, we are anyhow conducting it this month. The second internal is somewhere in September. And the third internal, which we call it as the pre-final, where you have paper 1, pre-final 1, and paper 2, pre-final, will be held in December. So this is the short period of time. Already 5th month is over. Another 15 days, you will be left with another 5 months. And there the rush will start and your tension will start building up, because the things will move on fast. And I'm not sure when you will come back to the college, and when you are coming back to the college physically physically to attend the classes here. Most of the time we will be spending around in training you for your practicals. In practicals in physiology, we have got 2 sections. One is the hematology and the other is the clinical examinations. So most of your time will be spent in joining for these 2 sessions, practicals, that is the hematology side and the clinical side, and the rest of the classes we will be conducting written examinations and some small group discussions. Now coming on to your first internal exam, we have set the dates as 28th, 29th and 30th, that is Monday, Tuesday and Wednesday. Last week of June you will have your exams. Now this exam is little different from the regular internal exam which we used to have. The internal exam is basically a 100 marks paper. Here we have divided this in physiology. I am talking now purely of physiology. In physiology, we have decided that we will conduct an 80 marks written paper, and this 80 marks written paper will be an online exam. In this, the split up of the 80 marks will be, you will have 2 questions. Question 1, 1 major question, 2 major questions, 15 marks each. And then you will have short notes of around 5 marks, 7 questions around for 5 marks. And then the rest of will be for 3 marks, let's say 10 questions of 3 marks. So in this way, the 5 questions of 3 marks. So 15, 30 marks for the 2 essays, 35 marks for 5 marks questions, and another 15 marks for 5 questions, 3 marks each will be very short notes. So this is around 80 marks of your written exam. After which, once you complete this on Wednesday, that is on 30th of March, once you have completed your written online exam, we will be conducting a oral exam or a viva exam from Friday onwards, that is somewhere around 2nd. On 3 dates, we will let you know the timetable. Let us say that is Friday, that is 2nd, then on 5th, that is the next Monday, and on 9th, that will be the next Friday, the whole 150 of you will be divided into 3 batches, and between lunchtime, that is 1:30 to 3:30, we will be conducting a Viva on Zoom, where face to face you will be split up and each of us will ask you questions on a particular topic. So that will be the Viva marks for 20, that will be the Viva exam for 20 marks. So this combined 80 plus 20 will have 100 marks internal assessment. Similarly, I think the biochemistry and the anatomy people will also conduct the exam in a similar way, where 50, 60, 70 marks or 80 marks will be the written online exam, and the rest of the marks will be given for a Viva, where the Viva will be conducted on Zoom meeting. Now, as far as the teaching program is concerned, I have just uploaded the timetable for the month of June for physiology on the website. You can have a look at it, come prepared for the class. In the whole month of June, we will be dealing with the respiratory system. July and for first week of August, we will be completing the CVS. By September, end of the September, the other two systems, that is the GIT, renal and the reproductive physiology will be, we plan to complete it by September. October and November will be for total CNS physiology, that is the central nervous system, the peripheral nervous system, the autonomic nervous system and the special senses. So this is the broad outline for the academic schedule for the next 4 or 5 months, and the micro details, that is the day-to-day teaching in the classes, will be uploaded in the month-wise program and it will be let known to you. If you have still any doubts regarding anything, you please mail it to me and I will reply it back whatever your concerns are. Secondly, in the first 2 months I had seen that I was receiving some queries and some faculty were also receiving some mails regarding some subject doubts. But last 2 months, though I have been telling in my classes, if you have any doubts, please mail back to you, please mail it to me. We will spend some special hour solving or clarifying your doubts or repeating some topic. But I find that in last 2 months, none of you 150 students have responded to that, either meaning that either you have perfectly read and understood everything, or you are just not reading at all. You are just whiling up your time. I can conclude only these two things, and wishing you all the best. I will start my respiratory system classes from today. Now, today in the yesterday's class, a brief discussion or a brief session was held where you were taught about the anatomy of the lungs, anatomy of the respiratory tract and the respiratory passages, where a brief overview was given about the anatomical structure of the airway, beginning from the nose, the nasopharynx and the larynx, the trachea, the larynx, the trachea and the subdivisions, the right bronchus, the left bronchus, and ultimately dividing into a number of bronchi, dividing into a number of alveoli. A brief histology of the class was also taught, where what are the epithelial cells, where we have got two types of respiratory cells, the type 1 cells and the type 2 alveolar cells are there, and they help in secreting the mucus and their functions were told. Today, carrying on the discussion from here, we will discuss about the functional aspects of the respiratory tract and its sequence and importance in helping the functioning of the normal cells, so that oxygen is reaching the tissues and carbon dioxide is exhaled from the body. Now this is a small diagram you might have seen multiple times, where you find that there is a respiratory system and the cardiac system, that is the cardiovascular system, integrated. We know that both the cardiac system, the vascular system and the respiratory system work in cohesion. Work in cohesion means the function of the lungs is to provide or to take oxygen from the atmospheric air. One function. The other function is it pumps out carbon dioxide from the lungs into the atmosphere. That is, ventilation is one of the important functions of the respiratory system. Now, what exactly does this ventilation means? Ventilation means the oxygen entering into the body, into the lungs from the atmosphere. This oxygen getting transferred into the blood, and from the blood the oxygen being carried to the tissues. So this is the one of the functions of the respiratory system, and it is called as an external respiration. So what does external respiration means? It involves 4 steps. The first step is that the oxygen which is present in the atmosphere has to enter into the lungs. Second, once it enters into the lungs, that is into the alveoli, this oxygen within a fraction of a second has to get transported or moved from the alveoli in the lungs to the blood which is present in the lungs, that is oxygenation of the blood. So this transport has to take place. This transfer of gases has to take place from the alveoli into the circulation, that is the pulmonary circulation. Once the blood is oxygenated there, the oxygen has to get transported from the lungs into the different cells or to the different areas of the body, so that the different cells and the tissues receives this oxygen. So blood which is oxygenated at the level of the lungs now has to move from there into the tissues and reach the cells there. Once it reaches the cells, this oxygen has to get transferred from the lungs, from the circulation into the tissues, and the cells which are taking up this oxygen will now give back the carbon dioxide. The carbon dioxide is transported back into the lungs through this circulation, and once the deoxygenated blood or the blood with carbon dioxide reaches the lungs, it has to be exhaled into the atmosphere. So this is the basic function of the respiratory system, and it is called as external respiration. What is internal respiration? Internal respiration is the biochemical processes or the enzymatic processes that are happening within the cell to utilize this oxygen, generate this energy and liberate the carbon dioxide. That is a different topic at all, that is internal respiration. In this topic, in this session of respiratory physiology, we are just concerned how oxygen enters from the atmosphere and reaches the million trillion cells present in the body, and how carbon dioxide from those cells is ultimately liberated out through the lungs into the atmosphere. That is external respiration. Now, in this whole process of respiration, if you notice, exchange of gases is taking place. To move this gas or to move this oxygen from the lungs to the tissues, we require the help of another system, that is the cardiovascular system. So what is cardiovascular system, or how is cardiovascular system helping in the respiratory system or working synchronously with the respiratory system is, once the blood gets oxygenated, the heart pumps this oxygenated blood through the various chambers, and this pumping action of the heart generates a force, and this force is now responsible for moving the blood from the lungs through the arteries and the arterioles and the capillaries. And once this oxygenated blood reaches the capillaries, exchange takes place, and once this exchange of oxygen takes place with carbon dioxide, the carbon dioxide enters into the venous circulation, and the same pumping action of the heart sees to it that the blood reaches back into the right atrium and the right ventricle, and then that goes into the lungs for oxygen to be liberated into the alveoli and to the atmosphere, and oxygen to enter. So this is what we are dealing here. So this whole out of these four processes, where process number one or step number one, oxygen entering into the alveoli. Second, step number two, transfer of gases taking place across the alveolar membrane and entering into the circulatory system. Third, the transport of gases taking place, that is transport of oxygen taking place from the alveoli into the tissues. And fourth, carbon dioxide getting into the circulation from the tissues and reaching the lungs. So these are the four stages or the four steps in respiration. Today we will be dealing about the first step, how oxygen will enter from the atmospheric air into the alveoli. So if you see the diagram, you will find there two lungs are depicted here. This is the heart, this is the arterial system, which we call it as this is the systemic circulation, and from this systemic circulation you will find that here it is returning back, and then this deoxygenated blood pumped back. Okay, this deoxygenated blood carrying to the alveoli. Here carbon dioxide goes out, oxygen enters. The oxygenated blood then is pumped by the ventricles, that is the left ventricle, into the aorta, the ascending aorta, the descending aorta here, and it reaches into the capillaries. In this capillaries, two things again take place, where oxygen enters into the tissue, carbon dioxide enters back into the capillaries. So this oxygen is lost here, it becomes deoxygenated. The deoxygenated blood takes up the carbon dioxide, and this blood with high levels of carbon dioxide is carried through the veins, that is the inferior vena cava and the superior vena cava, and reaches into the heart, that is the right atrium, the right ventricle. From the right ventricle, you will find that it comes out as the pulmonary artery. The pulmonary artery carries this oxygenated blood into the lungs, and in the lungs you will find that it loses carbon dioxide. When the pulmonary artery loses carbon dioxide to the alveoli, oxygen enters in. When oxygen enters in through the pulmonary veins, this blood, now oxygenated blood, reaches through the four pulmonary veins into the left atrium, the left ventricle, and this left ventricle pumps it, which we call it as circulation. So two circulations are there. Here this is the systemic circulation and this is the pulmonary circulation. And in addition to this pulmonary circulation, we have got a small amount of circulation where the blood is, oxygenated blood is also needed for these lungs. So these lungs are also living cells. They also require oxygenation. So the oxygenated blood is supplied to the lungs by means of bronchial circulation. So the bronchi and the bronchial circulation provides, the bronchial arteries provide oxygenated blood to the lungs. Now, what do we mean by definition? What does respiration? How do you define respiration? Now, respiration is defined as a complex process by which the organism meets its oxygen requirements and eliminates the carbon dioxide from the body. Right. Now, what are the steps involved in this whole respiration? Now, the whole steps, as I said earlier, the steps involved is in the mechanics of breathing is atmospheric air entering into the alveoli, oxygen entering into the alveoli, oxygen getting transported across the alveolar membrane, taken up by the pulmonary circulation, the pulmonary blood getting oxygenated, then this oxygenated blood being pumped by the heart and the oxygenated blood reaching the various cells in the body, the cells utilizing this oxygen giving up carbon dioxide, the carbon dioxide carried by way of the veins reaching again the heart, and from heart through the pulmonary artery to the alveoli, and in the alveoli the carbon dioxide getting transferred from the circulatory system into the alveoli, and from the alveoli through the process of expiration it is breathed out. So we have got two processes, one inspiration and expiration. So breathing basically involves two steps where it is, there is first step is inspiration, the second is expiration. So what is inspiration? The process by which the air enters into the alveoli is called as inspiration. The process by which the air is exhaled out from the alveoli into the atmosphere is called as expiration. So remember two steps here. One is inspiration and the other is expiration. So now the next question is, how many times do we need to breathe per minute? So what is the respiratory rate? So if you see here, there is a physiological difference or a variations in the respiratory rate. A normally adult will breathe around 10 to 12 times per minute, or 12 to 15 times minute. Broadly you can say it is 10 to 15 times per minute. So the respiratory rate is around 10 to 15 per minute. And what do you mean by 10 to 15 minute? That means one respiratory cycle is including of the process of inspiration and expiration constitutes one respiratory cycle. So in a minute an adult will have such 12 to 15 respiratory cycles, and that is called as the respiratory rate. So the adult respiratory rate is somewhere around 12 to 15 per minute. Note this here. At birth, that is at birth means when the child is just born, the respiratory rate is around 30 to 40 per minute. As the age advances, in the first year, it becomes around 25 to 30 per minute. By the end of 5th year, it is around 20 per minute. In adolescence, from the 5th year or 20th year, it still comes down to 20 to 21 per minute. And in adults, it is to the max around 15 per minute. Now, what is the importance of knowing this respiratory rate? The importance is that you should have an idea of the variations of the respiratory rate with age. Suppose tomorrow in the clinical side you are seeing a child or a newborn at birth, and when you count the respiratory rate, if you are counting it as a 30 to 35 per minute, you should know that physiologically the 30 to 35 per minute is normal for a newborn. 25 is normal for a first year child of 1 year. For 2 to 5 years, 20 is normal. If you don't remember these values and if you count suddenly out of ignorance and you find and you count the birth rate at 30 per minute, you will feel that you will misjudge or misdiagnose as a high respiratory rate or a tachypnea. So you should remember this, that with a low age early in life, the respiratory rate is high. Then it also helps you to diagnose whether the person is in distress or not. Suppose if a person, instead of breathing 12 to 15 times per minute, breathes around 20 to 25 per minute, that means the respiratory rate is high. That means that the person is requiring more times to breathe to supply oxygen to the body. So that is called as a respiratory distress, where under resting conditions, if you find that the person has to breathe more number of times, that means that there is some factor which is not allowing oxygen to reach to the tissues with a normal respiratory rate, and the person has to breathe more number of times so that the oxygen levels in the body is maintained. So that is called as respiratory distress. And especially so, you should have an idea in infants. Say for example, you are examining a child or in the neonatal ward where the respiratory rate is expected to be around 30 to 40 per minute. If you find that the respiratory rate is increasing to around 60 per minute, immediately you should get alert that there is a high respiratory rate. The respiratory rate is high because there is a increased demand of oxygen, or the body is not able to supply oxygen at a normal respiratory rate. So the respiratory rate is increased and there is some respiratory distress. So unless you know the normal values, you cannot diagnose or cannot see the distress. So it is important that you remember these values and appropriately analyze and come to a conclusion. Next, so in general, you should remember that with age, that infants or in children, the respiratory rate is high. As age advances, the respiratory rate slowly comes down. Now another thing which you should know is the tidal volume. Now what is tidal volume? Now tidal volume is the volume of air which you breathe in and out during each respiratory cycle. I will repeat the whole thing again. A respiratory cycle, one respiratory cycle includes one cycle of inspiration and expiration. When you breathe in and out once, that is called as one respiratory cycle. And in each respiratory cycle, the amount of air which you take in and leave is called as the tidal volume. So at birth, the tidal volume is somewhere around 10 to 20 ml. At the age of 5 to 15 years, the tidal volume is around 200 to 300 ml, and in adults, it is somewhere around 500 ml. So two values you have to remember. An adult, the normal respiratory rate is somewhere around 12 to 15 per minute, and the amount of air which he breathes in and out during each respiratory cycle, that is the tidal volume, is around 500 ml. Now, so in 1 minute, how much amount of oxygen is being breathed in and out? Multiply this 500 into 12 or 500 into 15. So around 6 liters, 500 into 12, let us say 6000 ml. So 6 liters of oxygen is breathed by a person in and out during 1 minute. And if this 6 liters this 6 liters is sufficient to supply adequate oxygen to the body. Similarly, in a child newborn, if you go back and see, 30 to 40 is the respiratory cycle, and in each inspiration and expiration, the amount of air which it takes in and out, that is the tidal volume, let's say is around 200 ml. So per minute, it is somewhere around 800 ml, 500 to 800 ml of air is breathed in and out by a newborn. Similarly, for 5 to 15 years, multiplied by the respiratory rate into the tidal volume, and that will give you the alveolar ventilation. So when you multiply the tidal volume with the respiratory rate, it gives you alveolar ventilation, and for a normal adult, the alveolar ventilation is somewhere around 6 liters per minute. Now we have been all talking about till now about the respiratory rate and the tidal volume. Now let us see what is the oxygen requirement by the body. We know that the oxygen is being utilized by all the cells of the body, which we call it as the BMR. So for a normal functional BMR, we require around 240 ml of oxygen per minute. So for all the cells to be functional normally, the oxygen requirement will be around 240 ml per minute. In an adult male, in an adult female, it is around 200 ml per minute. Whereas at birth, it is around 23 ml per minute. By the time child goes up, the requirement increases. And why does this requirement increases with age? Because the body surface area increases, so the requirement of the oxygen by the tissues also increases. So it is around 80 ml per minute. By the time the child is 5 years old, the oxygen requirement is 100 ml per minute. By 10th year, it is around 150 to 175 ml per minute, and by the time he is adult 2021, an adult male requires 240 ml per minute, adult female requires around 200 ml per minute. Now you go back and search for the answer why the female oxygen requirement is comparatively less than male. Why do the males require 240 ml and the females 200 ml? Now this is the oxygen requirement for the body to be functioning at a normal levels. Now correlate the three things. I have given you the data. I have given you the requirements or the data for the respiratory rate. I have given you the tidal volume, and I have given you the requirement. Now see the thing, for an adult to have 240 ml of oxygen per minute, he has to breathe around 15 times per minute with a tidal volume of 500 ml. So that means 500 ml is the tidal volume, 12 times is the respiratory rate, if he breathes with a tidal volume of 500 ml 12 times in a minute, the oxygen supplied to the body is at a rate of 240 ml per minute. Now, either if the tidal volume gets reduced or if the respiratory rate gets altered, the requirement of the body oxygen will have to be adjusted proportionately so that the body gets 240 ml per minute. So this is how the hypoxia comes in, where the person breathes in at a higher rate. This is what I was telling you, what is respiratory distress. The body requires 240 ml per minute of oxygen. For instance, if the tidal volume gets reduced, it gets reduced by half. So instead of 500 ml, if the person breathes only 250 ml, so to supply 240 ml of oxygen to the body without compensating or without any damage, the respiratory rate has to increase. It has to double it so that the 250 ml per minute of oxygen is supplied. So if the alveolar ventilation is 6 liters per minute, that is 500 into 12 is 6 liters. If the person is breathing at 6 liters per minute normally, all the cells will receive the oxygen at a rate of 240 ml per minute, and that will be sufficient. If for any instance the requirement goes up, then the ventilation has to increase, the alveolar ventilation has to increase, and if the ventilation